Mad. All right. Math 35, day 20. We're getting there. Today we are doing 12.4, which is ellipses, and 12.5, which is hyperbolas, which have very similar equations, but drastically different graphs. The ellipse also has an equation that's pretty similar to a circle. So let's start off talking about a circle. If I have x minus h squared plus y minus k squared equals r squared, we know that this is a circle of radius r, which means from the center I can go right r and I can go up r. In fact, I can go any direction r, but up, down, left, right, r. And the center here is hk. Now, I'm going to divide through by r squared because I want to show you how this compares to ellipses. And it worked really well in 335. They were graphing before I even showed them how to graph it. So I'm guessing you guys are going to do well with it too. These both show the same thing. This equation and this equation both graph that circle. That's a circle. Maybe I'll write circle because it may not look like a circle. It may look like an oval. It does kind of look like an oval. It's a circle. Ellipses look like ovals. So I can have an oval that's kind of flattish, or I can have an oval that's kind of goes up and downish. And there's a way to do it at a diagonal, but you guys don't want to do that. Again, I'm going to put the center at HK on both of them. But now the distance left and right does not equal the same distance up and down. So let's give it a different letter. Left and right, we're going to go A, and up and down, we're going to go B. How that edits our equation? Well, we use the letter underneath it to decide the change in x's. So the letter under this one, the square root of it is r, so we went left or right r. If I want to go left or right a, I need to have an a squared on the bottom for x. If I want to go up and down b, I need to have a b squared on bottom here. This is the general equation for an ellipse. Its center is HK. And we'll have points at H plus or minus A, comma K. And H and then K plus or minus B. Like up here is K plus B, down here is K minus B, but we still have the H. This point is left, so we have H minus A. And you don't need to memorize these, but just show them what they are. The helpful way of doing this to draw the ellipse is don't memorize these. go left and right A from the center, up and down B, and then connect your 4 points in an O. So the only real difference is we don't have the same denominator. Circles have the same denominator. Ellipses are different. Different bottoms. Let me pause, let that absorb for a second. Okay, so if I wanted to make it kind of look like our circle one, let's multiply by a squared b squared. And I would end up with b squared times x minus h squared plus a squared times y minus k squared equals a squared b squared. I wouldn't memorize this. It's not helpful in the form. But why I did it is, notice we have different coefficients. For x squared and y squared. That's your indicator that this is not a circle, if it's in this form. Okay?
Question.
Yeah,
Would if you were trying to calculate the orbit of something around the star, and it was very elliptical, it would be like a circle at one end. Like it would kind of be.
orbits are elliptical. We're gonna actually talk about orbits next week. 12.6 adds more stuff to parabolas, ellipses, and hyperbolas called focal points. And the sun is a focal point for the ellipse. But we will go into that. So, let's look at some examples. We'll start off with something simple like x squared over 9 plus y squared over 4 equals 1. My center is HK. What is HK here?
0.
They're both 0, right? So the center is the origin. So A is what I do left and right on. And B is what I do up and down on. What is A's value and what is B's value?
A is 3.
A is 3 and B is 2. So recall that this is A squared equals 9 and this is B squared equals 4. X is always above the A, Y is always above the B. We take the square root. We get A equals plus or minus 3. B equals plus or minus 2. But these are distances. So negatives don't count.
So what would happen if one of these values? I guess it can't be negative.
Not for an ellipse. Why did he say it like that? What can have a negative value? I wonder what other thing I said I was talking about today. Hyperbolas will have one of these be negative. Not the A, but the A squared or the B squared overall. You'll see. So if we graph this, go to the center. Go left or right 3. Up or down 2. Jesus. Stupid allergies. Kind of like we did with the circle, we went left and right R, up and down R. Now we're going left and right A, up and down B. And just like with the circle, we're going to connect it in a nice curvy shape. Again, no diamonds. It should look kind of flattish along each point a little bit. Let me give you guys one to try. Oh, no, let's shift it first. Let's do one that we've shifted. So as Davis brought up already, one of the main or one of the uses of these is celestial objects like planets and moons follow an elliptical orbit. There's something called a whispering chamber, a room that is not round but elliptical. The focal points, like again, we're going to talk about next week, act as a spot where if you're on the focal point, you can hear everything that is at the other focal point, no matter how big the room is. The Philadelphia Congress room where they were doing the Bill of Rights and all that shit, where the Liberty Hall or whatever it's fucking called, is a whispering chamber. I think it is. Well, there's a whispering chamber related to the Congress, because Franklin knew how it worked, and Franklin put his desk at one spot and deliberately never spoke while he was at his desk. And his political rivals were at the other point, so he could hear all their strategies and what was going on. About to use some math and science and shit and use it to his advantage.
They have them in San Francisco on a bunch of streets. There's a bunch of chambers like that.
You can try them out.
Yeah, they work. It's wild.
Yeah,
It's super wild.
if you tour the Supreme Court, there's a whispering chamber near it. They take you to the congressional one there, and he will walk you over, but you literally have to be at that focal point. He had everybody put their heads as close to the center as they think, And you walk like 50 feet away and whispered.
Yeah.
And you had your head closed, you could hear everything that he said. You pull your head back like fucking a foot, and you can't hear shit. It's really neat. So where is my center here? What's my A and what's my B?
-2. -1.
Does anyone agree with Keith? What's A and what's B?
I think I got a -4 instead of a -2 because it's 2 squared, right? Or
Well,
am
the
I
square's
wrong?
on the outside. The
Uh-huh.
square just helps us with the shape. Don't square it to get the 4.
Oh, okay.
Yeah, don't distribute and do it. Don't do anything like that.
Would an A be -2/3?
No,
So this is A squared. And this is B squared. Remember, the general form is x minus h squared over a squared plus y minus k squared over b squared equals 1. So that is worth memorizing. Memorizing this form is helpful because all the information you need for the ellipse is stripped right from it. So A is going to be 3 and B is going to be 4. And you go left and right 3. And you go up and down 4. That doesn't look very good on on the paper. My angle looks right. This should look taller than it is rounder. And this is, I'm not using graph paper. It might look a little skewed. Because it looks kind of like a fucking circle. But 3 and 4 is not, it's not gonna look very far off from a circle.
Yeah, it would be a negligible difference.
A big enough number, yeah, it's gonna look negligible. Okay, so one other thing I want to point out that the other group didn't see is the concept of the major axis and the minor axis. So the major axis is the length along the longest what do I want to call this? It's an axis. And minor axis, well, major axis is where it is. That's the longest axis. Its length is 2 times A or 2 times B. The minor axis is the shorter axis. In this picture here, this is the major axis. Here is x equals -2. On this one, the major axis was right here. The horizontal, and it was y equals 0. So the length of the major axis is 2 times the B on this one, which is 8. And up here, the length is 2 times A, which is 6.
It'd be like the diameter, certain.
It's the equivalent of like the diameter on a circle, but it's the longest diameter. And we don't really give a shit about the minor axis, other than if you know it, it can help you sketch it. The only thing that's added to this information is endpoints of the major axes are the vertices. Vertices is plural for vertex. So that's a vertex right here. And over here. It's on that one.
That's as in if you smash. It's together.
It's the same word.
It's the same word, but it's.
I don't know why they use the same word, to be honest. It is almost like smashing 2 parabolas together, but like. I don't know why they chose it. Cause they mean drastically different things than this.
And points was taken.
I don't know why they felt the need to give it a special name.
So for the major axis, is it just like? Whichever one, like whichever A or B is like greater, that's
Yeah.
where it's going to be.
Major axis is the. Along the greater of A and B.
And it'd be x equals -2 because that's where it happens.
That's the line, and even though that, which is interesting. That's something to point out. Like if the major axis. Is along. Is with B squared. The axis of symmetry. Or the major axis. Is x minus k or h. X minus h equals 0. Or x equals h. And if the major is with a squared. Here, the longer way is like this. So that's a y equals something. And that's a k. So axis of symmetry is y equals k. It's the other letter than the one that's below. Again, I don't know how important the major axis is. In reality. In some things, it matters. Like the path of the planet. It's called perihelion and aphelion. Furthest from the sun and closest to the sun. Which are at the endpoints of it, and it affects our seasons. But not so much as the fucking tilt of the earth does. That's deep. We're actually closer to the sun in winter than we are in summer. But the tilt of the earth has us pointing the sun in winter or summer. Even though we're further away, we're pointing towards it. And in winter, we're tipped away so we don't get as much sunlight. The southern hemisphere gets the exact fucking opposite.
So just explode.
Except for them, winter is hot, summer is cold.
Crazy shit.
Crazy shit, yeah. If the fucking toilets flush fucking counterclock or the other clockwise too. It's fucking bunch of everything. Water flushes one direction. When it's spiraling, you hit the flush. Look at it when you, the only way to like put like preferably a clean toilet, like a little rubber ducky in there. And hit the flush and see which way the duck spins. In Australia, down under, like the southern hemisphere, it spins the other fucking direction. Alright. Why don't you guys do one? Take a couple minutes, and then we'll do it together.
Do you want us to do like graph it or like just find A and B in the center?
I would do it all.
Okay.
Graphing doesn't take that much longer. Not too hard, is it? Yeah. Is that sufficiently sinister enough? If not, I need to up my game.
Would it, I got a question.
Yeah,
Would it be prudent to stop this equation from being a fraction? I guess it wouldn't help us with it.
no, it actually would make it harder to see what the ellipse is. You could, if you multiply through by 100, it'll clear the fractions. But then it's harder to see what the how long the axes are.
Yeah, better.
In fact, the next equation, we're gonna start there and go backwards. Go the right direction.
So, but they would basically be the modifiers in front of,
Yeah,
it would be like, yeah, if there was like 5 for x minus 2. X minus 2.
you'll see. You end up actually getting the other number on it. The 4 ends up here, the 25 ends up here. You're multiplying through by 100. All right, center, A and B. 2, 2. Which part are you talking about, Roberto? What's A and what's B?
These two.
A is 5, B is 2, which is the square root of 25 and the square root of 4. So if I graph it, I want to go to 2, 2, drop a point. And then we're gonna go left and right 5. 1, 2, 3, 4, 5. That actually puts me at 7. And if I go left 3, or left 5, I'm at -3. If I go up 2, I'm at 4. And down 2, I'm on the axis. So let's put some points in. I fed V equals B. That was fucking stupid. Ain't no one saying shit, just let me. That fucking does not like equal distant. But I'm gonna do it. This is the graph paper is your friend.
Yeah.
I know, lopsided. Don't judge. Only I get to do that when I'm grading. So how long is the major axis? It is not 5.
14.
10.
I heard 5, 10, and I've heard 14. Anybody got anything different?
Doubling down on 10.
It's 2 times A in this case. It is 10. Where the fuck did you get 14?
I just slapped them together, I don't know.
Did you add A and B and double those?
So I guess somehow I'll just put them together, I don't know. It's the great.
So like this is A and it's 5, this is A and this is 5. 5 plus 5 is 10. All right, so they don't always come to you in pleasant form. Let's do a new page. Then we need a logger. I have an x squared and a y squared, which tells me it's gonna be one of these roundish looking things, or a hyperbola, which you haven't covered yet. We have different coefficients on x squared and y squared, so this is gonna be an ellipse.
What'd you say you can tell if it's an ellipse? Different coefficients.
Different coefficients on x squared and y squared. So what do I do?
$57, the other side of the equal sign, or first you wanna,
That's fine. I'm gonna group these other things together by the same variable. Okay, now. You wanna factor out the coefficient of the squared things for each of them. So for the x squared, I'm gonna pull out a 4. And I'm gonna leave a gap. And for the y squared, there is no coefficient, I'm gonna put a 1 there just to indicate that. We complete the square, we take the 8, we divide by 2, and we square it. And that's 4 squared, which is 16. I have technically added plus 4 times 16 on this side, which is 64. So that's what I need to add on the right.
And if you're putting square on the same side of the equal sign, it would be.
Subtract. Here, same process. And I have added plus 1 times 9 equals 9. So I'm gonna add 9 over here as well.
That gives us 16.
What?
That's
On the right side, it gives us 16.
Oh, the end result, okay. Yeah, okay, that's fine. So we have 4 times x plus 4 squared. Plus y minus 3 squared equals 16. All right, Megan, what do we do now? Any ideas?
Do you want to divide by 16 to make that side a 1?
We want this side to be a 1, so we did have to divide. But we want to divide, make this a 1. So we're gonna divide by 16. If you had divided by 4, you would have seen that you didn't have enough when you tried to do the ellipse. So how does this simplify? The easiest way to go about doing this, unless it ends up with a fraction, is take whatever you divided by and then divide by the numerator. 16 divided by 4 is 4, so this ends up being a 4 on bottom. 16 divided by 1 here is 16, so this ends up being a 16 on bottom. Which we could see there was nothing really changing in there. This is a 1 now though. So it sounds like Jackie likes this section too.
Yeah, it's
Yes, Jeff.
pretty easy. I like it.
Good. I said Ben Franklin. I was wrong. This says here John Quincy Adams did it at the state's capitol. Huh. Apparently the Mormon tabernacle at Temple Square in Salt Lake City is also one.
It's not weird in any way.
Right? So center,
-4, +3.
good. A and B. And major axis length. Major axis and its length. Let's do that. What's A and B?
2 and 4.
2 and 4. Now, major axis and its length isn't all that easy to jump to unless you memorize some shit. And fuck memorizing shit. Memorize as little as possible, am I right? So let's graph this mofo. And you go left and right 2 from there. And up and down 4. And once I've graphed it, especially when these numbers are drastically different, we can see the major axis is up and down. And it's going through x equals -4. So the major axis is x equals -4. Which is our h. And what's the length?
It's at 8.
It's 8. Because this was 4 and this was 4. In fact, if you do this when you're drawing it and put that in, I would do it in light pencil, so something you can erase. But it would help you see things a little bit better. Anyone know the area of a circle? The formula?
R squared.
Anybody know the area of an ellipse?
Oh, is it?
It is in its own way, but the r's are not the same.
Is it pi a squared b squared?
Just pi a b. This is r times r, this is a times b. That's a fun little fact for you. They might give you problems. We only got a couple minutes left for this section. But I want to give you some ideas on what to do. So they might tell you where the vertices are. And they'll tell you, they might tell you a point on the graph. 0.00 is on the graph. And they want you to find the equation. I recommend doing a little sketch here. Right? That's what they've given us, right? So what do we need for the equation? Let's write down the general form of the equation and start seeing what we have and what we're missing. We need a center, right? We need A and we need B. Do we have any of those? Or can we figure them out? And if so, how?
A is only at one and B is
A is gonna be 1 and B is gonna be 2. The way to go about thinking about it is vertices are endpoints of the major axis. So I know the major axis is this. That's up and down, that's a B, and those are both 2. From what looks like the midpoint along it, the midpoint along it is right there.
Well, we could also just do the whole. Calculating the center of the line, say,
Yeah,
you could just do the.
so find the midpoint without sketching it. We do, what we got? It's, remember, it's x1 plus x2 over 2, y1 plus y2 over 2. 1 plus 1 over 2. -2 plus 2 over 2
Will we ever,
gives us 1, 0.
will we ever encounter an ellipse that's not aligned exactly on x and y, or that's like diagonal, where the,
Yeah, but not in this class.
but it does, probably, it does happen.
There's ways to rotate an ellipse. Generally, we don't work with them because it fucks up the equation. We just, in reality, when you're working with, you realign the axes. And we can see graphically that 1, 0 was that midpoint, and that midpoint should be the center. And so we can see to go left here, we had to go left 1, which means we're going right 1 over here, and A equals 1. So what is my equation?
It's going to be x minus 1 squared over 2. No,
No,
hold on.
X minus 1 squared over 1. And then plus. X. Is it just X?
not X anymore.
Right.
Oh yeah, Y. Y squared, right? Because it's supposed to,
We got okay, right?
and then over 2.
4,
Oh.
E squared. And that looks funny. Because dividing by 1 makes you look like a scrub. Don't be a scrub. Don't be like my calculus 3 students. Act like they don't know what divided by 1 means. All right, we're gonna take a break. If you want to have something fun to try out while you're not taking a break, if you don't leave your spot. Other ones you could do, like vertices at -1, 7 and -1, 1. And minor axis has a length of 4. And find the equation.
Is there a calculation, I'm kind of curious with all this circle talk about a spiral? Or like anything like a circle that actually expands and during its path.
Yeah. Not in this class though.
It's like, that's way like.
You can see stuff like that when you actually do work with it, it's way later, and I don't even know that you work with it here. Generally, when you're working in spiral, you would do a polar coordinate where R is changing as theta changes.
I don't know, I was thinking about that, and then maybe you would calculate if you were tilting an ellipse, that would be like showing change in ellipse, where like if like planet, like the moon has a different ellipse every rotation, like it is slightly moving away from us. So the equation for the moon's orbit around the Earth is not exactly permanent, or it's slightly changing every year. It would be kind of like a spiral, but not really. Be like a mutation, slightly.
Do they have an equation?
Yeah, the spiral thing would be useful for moving something in and out of the gravity well. Because you have to orbit inside the gravity well a certain number of times before you get enough speed to edit. If you were having no power.
If you're in gravity well and you don't have power, you're not going out of the orbit. You are on a trajectory inward, not outward.
Well, I guess that's also a spiral, you know, something. Are moving closer and closer.
They do use it for slingshot effect to add escape. But they use the gravitational pull of the planet to, along with velocity, to help speed it up a little bit.
Yeah, I remember once upon a time there was a game, there was like a flash game somewhere. Like Newgrounds that had like that whole equation in the game itself.
Oh, you're right, the orbit does shift.
It would be a super tiny amount.
Yeah, it's not a lot, but it, yeah, 5 degrees is shit. But it does.
So
I wonder if it's shifting or if we're basing it on the wobble of the planet. I don't know. I didn't hit stop record. Oh, okay. Actually, since some of you are still in here, I'm gonna walk through this, just like, how would I do this? Let's see, I would sketch it. But now,
Right, well, it's gonna be, I feel like being able to do those calculations might actually be really useful for some of who's happening in shifts that's moving between planets. They're gonna need to know how to move through the gravity wells and how to achieve an orbit from outside.
oh yeah,
So it's like, that's gonna be those.
they have done this with satellites that we've launched that have gone to outside the solar system. We've used planet's gravity wells like Jupiter to slingshot to make it go faster.
The Voyagers,
Might be, I don't know the names.
those are the old ones.
So that gives me a B equals 3. And the length of the minor axis is 4, which means 2 in each direction. Three that way. So my center is at -1, 4. I got x plus 1 squared. A is 2 squared. And so I would write it as thus.
And I don't hate this.
That's a good thing. I don't hate it is always a good thing. So Johannes Kepler is the one that did all the math with the elliptical orbits and stuff. And there are, like Newton's got the laws of motion.
Yeah.
There's Kepler's laws of planetary motion. So the only one I remember is a planet swings out equal area in equal time, which is deep. Yeah, one of the laws is one of Kepler's laws. I don't remember which one it is. A planet will sweep out equal area in equal time. So if we picture like us, I'm going to exaggerate where the sun is. And this is the path of the Earth. Like when it takes. When it does this 1/2 here. Going from this side, like point A to point B here. And it's rotating this way, let's say this is area 1. As it keeps going to point C. I don't know if I picked C right, but area 2 is gonna equal area 1. So that. The degrees it sweeps out are actually different. From a focal point. I think it's from a focal point. Unless you're going into astrophysics, that's an unimportant equation. It was neat though.
So.
Oh, his first law of planetary motion is the elliptical path.
It's just like, no, I don't like this thing.
Elliptical gears is another use for them. I don't know, does a fucking elliptical machine have elliptical gears? I don't know why they call it an elliptical.
Elliptical gear would be- Oh, well, gear.
Oh shit, it says it, elliptical bike gears make it easier for the chain to slide off the cog when you, no. That's just like on a 10-speed bike.
Yeah.
Having an elliptical gear makes it easier to change.
Yeah, the chain.
It must not be very elliptical though, because they look like a circle.
Well, one thing would be, that is elliptical for sure, is a crankshaft. So the mounting points on a crankshaft, you have to have 2 focal points. Because you have the part that comes down out of the piston chamber. The part that actually is the actual center of the
Right.
pipe. So there's like all these connection points and they're all elliptical to each other. Where the center point on one side is where the actual core of the pipe is, and where the center on where the piston attaches is the end of the piston rod that goes up and down. So that would definitely be.
All right, Lauren, you ready? Hyperbolas. Hyperbolas. Hyperbola. There is not one equation that fits all for this. Sons of bitches, but they're not that different. Minus. We'll call that HK. The general way that this one looks like is it looks like 2 parabolas that open along the x-axis. It's 2 graphs in one. And the one with the y, they open up and down. And they should be the same distance. In this case, that would be A. And here it is B. How we're gonna graph, that's just to get the general idea of what it's gonna look like. So it's whichever one is positive. the arrows tend to point more in that direction when you're graphing.
So there's no asymptote.
There is asymptotes.
Yeah.
This is the asymptote one.
There's a couple, Henry,
What?
there's a couple asymptotes.
Okay. So how do we go about graphing this? We're gonna do the box method, which generates our asymptotes. This is the only difference between the ellipse and the hyperbola is this minus sign. And it completely fucking changes the graph. You know, just one little minus sign just fucks everything up. It's the wrench in the gears. All right. People should write, and I wanna wait. Are you taking notes from your phone? What the hell are you doing?
Cause I can't see.
Are you really looking at this on your phone? Like, are you on?
I'm just taking pictures of it and then copying it down.
Wow. Why don't you like move closer to the center where it's like directly in front of you?
But technically it is like right in front of me, I just keep looking up and down.
You need new glasses, girl.
I do.
Seriously, do. I got new glasses. I'm so glad I did. I've never thrown glasses away. I threw my old pair out as soon as I got these. It's like, wow, this is so much fucking better. The old ones, they're like bifocals. They were progressive, so they don't have the fucking big old chunky thing on me. But the last one, the bifocal part was like a fucking 2 millimeters, 3 or 4 millimeters long. It wasn't like the reading portion of my lenses were like, look through the bottom of my fucking glasses. And my job is reading. I do a lot of looking at screens and fucking shit like that. Looking at papers now. So this one, like, there's a much larger window where text is super clear. And like, they just fucked up my lenses on the old glasses, and I wore them for a couple years, and yeah. And it caused my eyes to change a little bit. All right. Everyone looks like they're done writing. So how do we graph these? We're gonna do something called the box method. Yeah, so go to HK. And just like the ellipse. Left and right A, up and down B. Let's say that's B along there, this is A along here. Now B. Make vertical horizontal lines so that you get a box. Do it very lightly, like light pencil. I'm gonna just do it very like, I'm gonna just put a couple dots doing this. I got my vertical line there. I got a vertical line right here. And then I'll do horizontal lines like through this. So that this is my box. Maybe I'll make my box red. The diagonals of the box are asymptotes. So it goes through the center and through the corners. None of these have graphed the hyperbola yet. And this is where they change a little bit. So D1. If it's x minus h squared over a squared minus y minus k squared over b squared equals 1. The vertices are left and right. I'm going to say this in a funny way, but it's going to be a long positive axis. This is going to be true for both of these. Y minus k squared over b squared minus x minus h squared over a squared equals 1. Again, a long positive axis. Y is going up and down, so the vertices are up and down. So these would be my D1 vertices. And these are my D2 vertices. Now, the same is true for both of these, starting at your vertices. Draw a curve that approaches the asymptotes, but doesn't cross. Yeah,
How do you know which is the accepted quadrants? In this, like how do you know whether it's D1 or D2 that has the graph in?
it's whichever one has the positive, the variable has the positive sign. So like the x is positive here, so D1 is going to be left and right, and D1 is going to open like do this. So that's D1. Those are my D1 points. Without putting them on the graph up there, those are the D2 points. And this one here, the y is positive, the x has got the negative in front of it. Here, the x is positive, the y's got the negative in front of it.
And the D1 and D2 points are not the center, but
They're not the center. They are out a distance either A or a distance B. And it's not always the longest one. That was an easy way to tell the ellipse, right? Whichever number was bigger, that was where it was longer that way. And we did it. That's no longer reliable. In fact, it's false 50% of the time. It's got to be whichever one is positive. So the way I picture these is, I picture these as if I made like little pew pew out of them, made like little things out of them. Which directions are these arrows pointing in? These are pointing up and down, Y. These are pointing left and right, X. But the blue lines are not part of the graph. It's just that they look like parabolas, but parabolas don't follow asymptotes. So they got that curved look to them, but it's slightly different. Every single one of you has seen an hyperbola. You may not have seen it in person, but you have seen it. That's a shitty pit. Why? The Gateway Arch in St. Louis, Missouri is constructed in a hyperbolic pattern.
I was literally just thinking.
There are other uses for it. I'll tell you more about them on next week when we're going over focal points and stuff like that. Let's go through doing some of these. Like this is the general instructions, but as soon as you do a couple, it's not too bad. I promise. The Gateway Arch is really neat when you go there. If you go in it, you can go in, it's hollow. It's got an angled elevator that takes you up to the top, and then you get to the top. And it's got like viewpoints and shit that you can see out, but fuck St. Louis is a fucking concrete swamp. Like fucking the humidity levels off the fucking chart. But it's concrete and it's hot, so the humidity is amplifying the sun. And then it's, so the general heat's hot, and then it's fucking humid. And there's no fucking shade because it's all concrete. There's very like, even in the shade, no, it's a fucking just a miserable place to be. All right. So am I doing left, right? Or up, down? Who here thinks left, right? Who here thinks up, down? Well, I only got 3 votes, so they were all for left, right. It is in fact left, right. Even though the 25 is bigger, it's left, right. Where is the center?
0, 0.
Center's at 0, 0. There's nothing listed in the parentheses, so it's 0, 0. What is my A and my B?
2, 5.
2 and 5. I'm gonna go left and right 2. Up and down 5. I gotta rotate it so I can see a little bit better. I'll rotate it back in a second. There you go. That's my box. I connect my diagonal points of the box passing through the center, but use a dotted line for asymptotes or a slash line for asymptotes. Everyone okay with what I've done so far? Not excessively hard. I didn't show the box drawing, I just went to the corners and put points. Because I don't have a pencil where I can erase very well, and it looks shitty having too many lines on your graph. So, but it's like, these are the corners of the boxes. Maybe I'll label the box corners. B1, B2, B3, B4. Those are my box corners. And now I know it opens left and right. So what I'm gonna do is start, that makes this a vertex. B2 here and B1 here. I'm gonna just start, make a curve that goes towards it and then follows along it asymptotically. And if you want more precise than that, you need to do like a graphing calculator computer.
Is there a relationship? This and the graph where those asymptotes are X and Y. Is there like a relationship between those two equations?
Where the asymptotes are X and Y,
Yeah, where
that's kind of like 1/x².
that's
Or 1/x. That's a reciprocal relation has it.
is there like a
Not really, because y equals 1/x. Has that type of behavior, but I wouldn't call it a rotated hyperbola.
You could have a hyperbola. You could have a hyperbola that's more hyperbola based on the circle. Where they're the same,
I don't know what you mean by that.
where the asymptotes are perpendicular. So it would be roughly.
Oh, what makes the asymptotes perpendicular? How could I get asymptotes that are perpendicular?
If the number, or if there was a number on the bottom.
If A equals B.
Yeah.
Then your lines are gonna look like that.
Yeah.
It'll be a square, not a rectangle. And so the diagonals will cross at a right angle. So kind of like a center, but with a minus sign. Okay. If I wanted to do, and I'm gonna do it on the same graph right here, but a different color. Y² / 25 minus x² / 4 = 1. So I'm gonna point at my two graphs here. Exact same setup. Exact same box. But our vertices here would be V2 and V1 up here. And so we're gonna do this. I only showed them on the same one because I just used the same equation and changed the sign. You guys ready to move it? We're still writing, and giving y'all a little bit longer. Now, what do you think, Jackie?
It's okay. It's not too bad.
It's not too bad. Just circle and ellipse are definitely easier. I agree. There's
Yeah.
a couple more steps. We got to make the box and the asymptotes. And then you got to remember which way they go. Because it's not always along the bigger number.
No. And that's okay, but I don't want it to go further. Like I'm okay just verifying that and that's it.
That's as far as we're going today. We're going to move the center. And we're going to do one with the complete the square, but other than that. So let's move the center. You ready? Yeah, that look on your face like I yanked. Is anyone ready? Is everyone ready? You're not, if I yank it too early, you need to say something. I don't pick the same numbers. So what's my center? And what's A and B? And which way do I open? Up and down or left and right?
Left and right.
We're gonna open left and right. Yes. The X is the positive term. What's the center?
-1, 2.
That looks right to me. Keep going, Jackie. Floor's all yours.
A equals 7, B equals 3.
Anybody disagree? Look good? Okay. So -1, 2. All right, and I only need to go 3 up and down. That's pretty fucking easy. I go left and right 7. What?
The bottom of this, yeah.
Thank you. All right. I'm gonna do a light box in red. And I'm just using dots. From my center, I draw slashes towards the corners of the box. And you gotta go well past the box because the hyperbola does not show up in the box. Forgive me while I rotate the camera to do the other one. It's hard to draw a straight line towards a specific spot if I'm doing it sideways. But if I'm doing the line towards me, my little fucking red shit just veered, didn't it? There you go. The actual graph does not have the asymptotes on it. If you put this in Desmos, it'll show you what it looks like. It might ask you to have it solved for Y though. I don't know if it'll do it the way it is. So. Now what, Jackie? You're my only hope. That was a Star Wars thing. It said Star Trek. That was not a comment on anyone in here.
Well,
That's
we can
fucked up.
label those endpoints as like V1, V2.
Which ones?
Uh,
Left, right endpoints or up, down endpoints?
Left, right endpoints. And then we can draw our parabola without going over the asymptotes.
It sure looks like a parabola, doesn't it?
Uh-huh.
I know I describe it as a parabola, but parabolas don't have asymptotes. The fucking thing's changing all the time.
This is a hyperbola.
It's a hyperbola. But they look a lot like parabolas, don't they? Looks like two parabolas. But they are not. Parabolas do not have asymptote. Not have asymptotes. And so like the way this keeps looking different is if you go further out, at some point, this starts looking a shitload like a straight line following it. But a parabola, like the hyperbola, keeps following the line. Whereas a parabola, as it gets further away, is curving inward more. I think the up and down parabola is easier to see. All right, misjudgment, how do you feel about that one? Is doable? All right, good. Who else wants to be picked on? No one, all right. Let me give you guys one to try. What's my center?
-2.
-1, -10.
Oh, which one is it?
It's
It's the second.
Second.
It's like -2.
Dirty trick, huh?
Very-
It's something you just gotta pay attention for.
Whole graph is fucked up.
And so but you might go, if you. You just might be miscentered. If you've got the right shape, you've done everything else right for the center. You're doing pretty good. What's A and B? They're both 5. So this is kind of like what Davis was asking about earlier. What happens when they look kind of the same? All right. Moment of truth. Up or down, left or right? Down. This is a little easier to do if I do some shit like that. That asymptote looked like shit. Any questions?
So, I don't know, like I was asking earlier, is there any connection between this graph? Why?
No. Oh, I thought your question was something different. I thought you were asking if the asymptotes were like this.
No, if there's a connection between that type of graph and this type of graph. Like, because.
It's almost like a rotated y equals
Yeah.
1 over x. I don't know, I have to look into it some more. I don't know of a connection, but looks like it. I can understand the question. Huh. Anyone need that longer? All right. So we're gonna do the setup here, but not graph. I just want you guys to think about some shit going on here. Which parentheses do I move? Why?
If you moved like the Y parentheses. Oh shit, if you moved either of them, wouldn't it be a different graph for each one?
Well, you can explore, let's explore looking at what happens if we move y. If we move y, we have this. That's moving y.
for
if
that
I
one.
move X. What happens? I'm gonna have to put the 144 over here by subtraction.
They'll make the X positive and the Y negative.
If you divide by it correctly. If you did this by negative 144. Correctly, the X is going to be positive. And the Y is gonna be negative, and you're gonna end up with that anyways. But. It's easy to forget the negative sign when you're dividing. So I strongly recommend moving it so that your constant is positive. Choose such that your constant is positive. That's what I want you to gather from that. And then let's just give you a fun complete the square one. And we can do this together. So I'm gonna put the Y's together. And I'm gonna put the X's together. And I'm gonna move the 439 to the other side by adding 439 to both spaces. All right. Complete the square. For the Y, we're gonna factor out the 25. And I have Y squared plus 2Y. For the X's, I'm gonna factor out the negative 16. Which is gonna make my 64. 64 divided by negative 16 is negative 4. You guys with me? So make a note that sign change. It's easy to forget when you factor out a negative, it's gonna change the sign. All right, I complete the square here. What have I added to the left side? I've added 25 times 1, which is 25. So plus 25 over here. And complete the square here. What have I added to the left side here? Negative 64, 16 times 4, but negative. So I'll subtract 64 over here.
Yeah, and if we were completing the square on the same side of the equation, it would be
The opposite.
flipped to sign.
Yeah,
But since we're taking it to the other side of the equal sign, keeping it the same sign.
correct.
Is it?
I think that's 400, isn't it?
Yeah,
Okay, so what to do now, I hope is obvious. Divide by the 400, right? If this right side is negative. It's not a problem here. As we saw in the last one. If we just divide through by it. And it changes the orientation, the way that, which one's positive over here. On ellipses and circles. Right side can't be negative. Because we don't have that option of dividing by the negative and fixing it. Any questions? Are we having fun yet?
So the end equation would be y plus 1 squared over 16 minus x minus 2 squared over 25 equals 1.
Y plus 1 squared over 16 minus x minus 2 squared over 25, you said?
Yeah.
Yeah.
And then we divided by negative.
I divided by 400.
Okay.
So 400, one way to look at it is 400 factors into 16 over, or 16 times 25. So if I put. I'm still dividing by the 400 here. It's a little easier to see what cancels. All right, it's 5 o'clock. You don't gotta go home, but you can't stay here. Get the fuck out. No, actually, you can't stay here. But class is over. Any questions for the peanut gallery online?
No, we're good. Have a happy birthday.
Thank you.
You're welcome.